Hey everybody, I'm going to walk through the notes on reflections, and later on I'll do a video on just kind of working through just specific problems, but I want to just go over what a reflection is and just different things about it. So in a reflection, the figure is being flipped over a line of reflection, or one of the axes, or axes, I guess the best way to say it, so the y-axis or the x-axis. But the line that we reflected over is called the line of reflection. And this type of transformation preserves distance and angle. This is called a rigid motion. Okay. Again, a rigid motion just means that size and shape, or sorry, the size doesn't change. So this is what a reflection looks like. It's like I flipped something over a line, and one way I've tried to explain it to people is if you choose a point on what's called the preimage, and remember the preimage is the starting point, so if we assume this is where we started and this is where we finished, if I look at the distance of that point from the line of reflection, its corresponding point, which would be this one, is going to be the same distance from that line. And no matter what point you choose, that's going to be true. So if I chose this point, that's going to be the same distance. So if I look at its distance to the line of reflection, that's going to be the same distance as its corresponding point on the other side. And so if I was to try to draw this, if I wanted to draw C prime, so this is called a preimage, and we know that because we don't have those little symbols on the letters. If I want to draw C prime, I'm kind of just going to go the same distance away from the line of reflection. Same thing with B. And A, I'm just going to assume somewhere right there. Okay, I know that's not perfect, but one way to do that is, again, to look at the distance the letter or the point is from the line of reflection. Now let's actually look at some problems here. Reflection over the x-axis. So we're going to talk about what actually happens when we reflect something over the x-axis. So if I reflect these points over the x-axis, it says, let's see, reflect each figure over the x-axis and label the vertices. So if I flip D over the x-axis, so if you don't remember, this right here is the x-axis. If I flip D over the x-axis, I end up here. Again, I know that because D is 1 away from the x-axis, and so I just go 1 on the other side. Well, where is that point located? Well, that point is located at -3, -1. So D becomes -3, -1. So D was -3, 1. D prime is -3, -1. Now let's do A. A is 1, 2, 3, 4 away from the x-axis. So we're going to go 1, 2, 3, 4. So that's A prime. And that point is located at -3, -4. So we're reflecting each point. So if I do that with each point, I'm just going to do that quickly. And I actually figure out the points. What do you notice about what's happened from here to here? Well, the -3 didn't change. But notice the +4 became -4. The +4 here became -4. The 1 here became -1, and the 1 here became -1. And what the rule is when you're reflecting over the x-axis is this. So the rule is x -y. Now what does that mean? All that means is when you're reflecting something over the x-axis, the only thing that's going to happen is the y value is going to change its sign. So if it was negative, it's going to become positive, and if it's positive, it's going to become negative. So I could draw it up here, but just to show you what I mean by here, -4, 5 is going to become -4, -5. Notice, all I did was change the sign of the y value. That's all that happens when you reflect it over the x-axis. 2, 4 is going to become 2, -4. 3, 0 is going to become 3, 0. And again, it doesn't change because 0 doesn't have a sign. So I can't change that sign to its opposite. Now, just so you kind of understand, let's imagine I had A as 5, -2. and I wanted to reflect it over the x-axis. Well, a prime would be 5, positive 2. So if the value of y is negative, it becomes positive when you reflect it over the x-axis. And if it's positive, it becomes negative if you reflect it over the x-axis. Okay. So the only thing that happens when you reflect something over the x-axis is the y value changes its sign. The x value does not change. Now, if I reflect over the y-axis, I would, go ahead and do this, but just for the sake of time, I'm not going to go through the drawing. But I'll just tell you, when you reflect something over the y-axis, what ends up happening is the x value changes its sign. So the way we would represent that is negative x, y. And so 2, 3 is going to become negative 2, 3. Notice the y value didn't change, but the x value changed the sign. 5, negative 3 is going to become negative 5, negative 3. 2, negative 3 becomes negative 2, negative 3. So when you reflect something over the y-axis, the x value just changes its sign. So again, same thing over here. All these, the 2, 5, 4, and 1, are going to become negative, or they're going to change their sign. And the y values don't change. So the basic idea is, so another, again, example, if I had negative 5, 2, and I wanted to reflect that over the y-axis, that would become 5, 2. So again, the x value changes its sign when you do that. Now, if we're asked to just reflect over a specific line, excuse me, this is kind of not focused. Let's see if I can focus it here. Sorry, that's the bell. Alright, so that's a lot better. Okay, so if I'm going to reflect it over a line other than the x and y axis, what I would really recommend doing is just doing it graphically. So instead of dealing with the points like I did up here, where I realized that I could just change the sign of the x value when I reflect over the y axis. Here, when you reflect over a specific line, all you're going to do is count how far it is from the line of reflection, and then count that many on the other side, and then label it A prime. Same thing with C. That's 1 away, so then I'm going to go 1 away on the other side. That's C prime. B is 1, 2, 3, 4 away, so I'm going to go 1, 2, 3, 4, and that's B prime. And as you can see, it is reflected over that line. So when you're reflecting over any line other than the x and y axis, you're just going to count each point and how far it is from the actual line of reflection. So hopefully this video helps. If you do have any questions about anything I've gone over, please ask me. I just want to review real quick. Again, if I were, let me write on that. Just a review. If I reflect over x-axis, all you're going to do is change y sign. So what I mean by that is xy is going to become x negative y. An example of that would be, let's say, 2, negative 3 would become 2, 3. Okay, notice all I did was change the y sign. That's an example of reflecting a point over the x-axis. If I reflect over the y-axis, you change the x sign. So what that means is xy becomes negative x, y. And an example of that would be 2, negative 3 becomes negative 2, negative 3. So again, notice the 2 changed its sign, the negative 3 did not change. Okay. So that's just a quick review. Hopefully this helps, and I will be making more videos.